When determining the calculated load for multiple ranges, you can treat them as a single unit because they operate on the same circuit. The calculation involves several steps. Firstly, combine the loads of all the ranges. Secondly, apply a range load factor to this combined load. Thirdly, multiply the result by a demand factor applicable to ranges. Let's illustrate this with an example of two 12 kilowatt ranges. The first step is to combine the range loads. We have two ranges, each rated at 12 kilowatts. So 12 kilowatts plus 12 kilowatts equals 24 kilowatts. The total load of both ranges is 24 kilowatts. The second step involves applying a range load factor. In many electrical codes and calculations, a load factor is used to account for the fact that appliances, including ranges, do not operate at their maximum rated power continuously. For ranges, a load factor of 0.5 is commonly used. So, we multiply the total combined load of 24 kilowatts by the load factor of 0.5. This gives us 24 kilowatts times 0.5 equals 12 kilowatts. The third step involves multiplying by a demand factor. A demand factor is another adjustment used to account for the diversity in electrical usage. For ranges, a demand factor of 1.6 might be applicable, though this can vary based on local electrical codes and specific installation conditions. Multiplying the result from step 2, which is 12 kilowatts, by the demand factor of 1.6, we get 12 kilowatts times 1.6 equals 19.2 kilowatts. Therefore, the calculated load for the two 12 kilowatt ranges is 19.2 kilowatts. Let's clarify why the initial calculation of 12,800 kilowatts is incorrect. The given calculation contains a series of seemingly arbitrary steps and multipliers without a clear justification based on standard electrical engineering principles or code requirements. The initial subtraction of 24 minus 12 equals 12, and then multiplying 12 by 0.5 equals 0.6 kilowatts does not align with standard methods for calculating range loads. The step involving 8,000 kilowatts times 1.60 equals 12,800 kilowatts is unclear in its purpose and appears to be unrelated to the actual load calculation for the ranges. The correct methodology, as outlined earlier, involves combining the loads, applying a load factor, and then applying a demand factor, all based on established electrical engineering practices and code requirements. In summary, to accurately calculate the load for multiple ranges, combine their individual loads, apply a range load factor to adjust for non-continuous operation at maximum power, and then multiply by a demand factor to account for diversity in usage. Remember to always consult the relevant electrical codes and regulations specific to your location to ensure compliance and safety. These codes provide specific guidelines and factors to use in load calculations, ensuring accurate and safe electrical system design. It's essential to understand the purpose and application of load factors and demand factors in electrical calculations. These factors help in designing electrical systems that are both safe and efficient, preventing overloading and ensuring reliable power distribution. Understanding these concepts is crucial for electricians, electrical engineers, and anyone involved in electrical system design and installation. Always refer to the most current edition of the National Electrical Code or other relevant standards in your region for the most up-to-date requirements and guidelines.